another friction problem. So let's level surface, and here's a box. And let's say the box has a mass of 2 kilograms. And now let's say there's a coefficient of friction between the box and this surface, mu is equal to 0.4. All right, and again, this thing right here, it's a Greek letter, mu, and it is used to represent what's called the coefficient of friction. And there are actually two different mu's. There's a mu for static friction. There's a mu for kinetic friction. So we'll say that this mu is kinetic friction because the two values are actually different depending on whether the box is sliding or not. So the question is, how much force do I need to push this thing with? In order for the box to slide with constant speed. The box is sliding to the right with constant speed. So how hard do you need to push it in order to achieve this, right? So, well, there's friction, and friction opposes slipping. So friction is acting in the opposite direction that the box is sliding. So friction is acting, and again, it's between the surfaces here, but I'm going to draw it right here. F. And since the box slides with constant speed, that means that the acceleration is 0. That means that the net force is 0. That means that this F, the applied force, has got to be equal to friction. Or, net force is equal to ma. So the net force, if we're looking at the coordinate system where this is the positive direction, that means that this force pulling it minus friction is equal to 0. That means they have to equal each other, right? So that means that the applied force here is equal to the frictional force. Okay, so how big is friction then? Well, friction, there's an equation for that. Friction is equal to mu times n. Right? And so we have the value here for mu is 0.4. And n, what is n for this problem? Well, I made a major mistake here. I didn't draw my free body diagram the very first thing, which I should have done. Here's mg. That's the weight of the box. And n is acting upward. And these two are equal to each other in this case. It's a level surface. There's nothing stepping down the box here. Right, so mg is 20 newtons. So n has got to be 20 newtons. So then mu times n, 0.4 times 20 is 8. So to keep this thing moving along here, the force pulling it or pushing it has to be 8 newtons. That has an n on it, by the way. So there you go. 8 newtons. Problem done. Let's try another one. All right, box. And this box has a mass of 3 kilograms. And there's a force pulling it to the right. And that force is 10 newtons. And you'll never guess what the box is doing. It's sliding with constant speed. Okay, it's sliding to the right with constant speed. And the question here is, what is mu? What is the coefficient of friction in this case? If the box is sliding with constant speed and this force pushing it is 10 newtons, so constant speed. Oh, all right, this means the acceleration of the box is 0. That means that the net force acting on the box is 0. That means that this force pulling it has got to equal this frictional force. Right? And then there's an equation for friction. Friction is mu times n. Right, so let's, and that means that mu is F over n. So let's just figure out here what n is. Well, there's gravity is acting down on the box here, mg. So 3 times 10 is 30 newtons. So that means that n is 30 newtons. Okay, so then friction divided by n is 10 newtons divided by 30 newtons. 10 divided by 30 is 1/3. So mu is, you could say 0.33. All right. And that number, that coefficient of friction, it doesn't have any dimensions. It is dimensionless. It's a ratio of two terms, both with units of newtons. And newtons over newtons is 1. So there you go. Problem done.